Okay, so we're going to do a quick run through of how this electroscope works and the conduction and induction charging methods. So right now I have a neutral electroscope here. It's straight up and down, and again I can touch the top to ground the electroscope and you can see it's remaining neutral in that upright position. So I'm going to take this plastic strip, this clear plastic strip, rub it with a little bit of fur, and what we're going to see happen is I'm going to get a charge on this plastic strip and I'm going to transfer it to the electroscope. So the plastic strip here has a higher electron affinity than the rabbit's fur, and it gains electrons from the fur and becomes negative. Now I place it on the electroscope. Some of the electrons on the plastic strip are going to be transferred to the electroscope. I take it off. Now we can see it's no longer neutral, it has charge. So there's some electrons that are kind of distributed through here, and they're now running up through here into the rod. They're distributed down here, and so all those negative charges that are all jammed in here are repelling each other up here, they're repelling each other down here, and so you see the electroscope in this position. Again, I can test that by saying, okay, all these extra electrons inside the electroscope, I can touch the top, take them all out, they go through my hand into the ground, boom, I've got a neutral electroscope again. Now the second charging method is called induction. So that was conduction, when I touched the actual charged object to the electroscope, transferring that charge. Induction involves me again charging the plastic strip, so now it's negative, but I'm not going to touch the plastic strip to the electroscope. So see, I let it touch, that's going to transfer the electrons, so let's ground this again. So now I'm going to put it there. I'm not going to touch the strip to the electroscope, I'm just going to push the electrons down here, then I'm going to touch the bottom here. Touching the bottom there means that all the electrons that were pushed to the bottom then exited to a place there was more room, which is in the ground, so they went through my hand into the ground. So I took some of those electrons that were getting repelled down into the bottom of the electroscope, and since I took electrons out of the neutrally charged electroscope, now that electroscope is positive. So again, I took this negatively charged strip, and now I've made the electroscope positive. So before, during conduction, I was touching the negative strip to the electroscope to give it a negative charge. Now I use the negatively charged strip to give it a positive charge. And I can test to see if it has a positive charge, because now there's extra protons down here, some extra protons that are now repelling each other. That positive charge is repelling itself. But if I take this negative object, it's going to push some extra electrons down there, and you'll see now those electrons are neutralizing the extra protons, and it becomes neutral. But if I move the plastic strip away, it doesn't do that anymore. So I'm holding the plastic strip above it. It's becoming neutral. Let me just show you that. And the plastic strip is above the electroscope. So I'm pushing those electrons down there, but I take it away, and those electrons redistribute themselves, and this part becomes positive again. All right, I can do, so again, conduction gives it the same charge as the plastic strip, and induction gives it the opposite charge. If I have something like this strip actually has a lower electron affinity than the first, so it will become positively charged. It'll give up electrons. And so if I neutralize this, I can give it the opposite charge that the clear strip did. Boom. I'm going to take this, I'm going to touch it to it. Now it has a positive charge, so the electrons are going into the green strip because there's extra room for electrons in that green strip. I've given it a charge here. Now I can see, okay, all right, so now I'm making this even more positive because all the electrons, any electrons that were remaining down here are now being brought up, so it's becoming more positive than it already was because it already had lost electrons. And I can also test it with the clear strip and say, well, maybe I can push some electrons back down there to neutralize some of that positive charge. Yep, and lo and behold, I have the clear strip here. I'm holding it close to the electroscope, and I have a positive, or I'm pushing those electrons down to neutralize the positive charge. I can do the same thing with induction. So ground it and make it neutral. let's charge up the green strip. So here's the green strip. I'm going to hold this close to the electroscope. Now I'm drawing electrons up, so there's some extra room for electrons down here. I touch it, I neutralize everything, so any extra room is filled with electrons. And then I take my finger away, take the plastic strip away. Gets a little bit of charge. Let's see if we can give it even more charge though. Let's neutralize this. Let's recharge that strip. Let's hold it here. Boom. All right, so now, remember this green strip had a positive charge. I'm going to give it I use the positive strip to give it a negative charge. Now I can test to see if it's negative. Yep, if I hold a positive green strip above it, it becomes neutral again. And if I hold a negative strip above it, it becomes even more charged. So that's a summary of conduction and induction with an electroscope. Hopefully that helps with a quick summary of what you did in class.